Good morning.
Good morning. It's starting in about a minute.
All right.
Okay, here we go. Any questions on the homework?
I was confused on number 6.
All right, let's take a look at number 6. All right, let's see. Number 6 says the following. It says, to the nearest percent, what percent of the world's 4.5 billion people live in the 7 nations shown on the graph? Well, percent, let's see. Let's think about what percent means. Percent means a number out of 100 or a part out of a whole. I'm going to choose to write part out of a whole. Part out of a whole. All right, so the whole would literally mean everything. So in other words, the whole is 4.5 billion. So let's see if I can write all those zeros. 4.5 billion would be 4,500,000,000. That's going to be a lot of zeros. That's 4,500,000, and that's 4,500,000,000. Sorry. All right, so there's my whole. So the part would be the question. It says, to the nearest percent, what percent of the world's 4.5 billion people live in the 7 nations shown on the graph? So in other words, there's 7 nations. The part would be those 7 nations. So I'm simply going to add those up. Now notice the numbers, it is a bar graph. So I'm just going to roughly do this in my head. So China's got about 1 billion. India's got about 650 million. Soviet Union, you can see how old this is. There's no Soviet Union anymore. 250 million. United States, 220. We're over 300 million now. Anyway, you're going to add up all of those numbers and you're going to get a number. So when we add up all of the numbers from the table itself, we get a number. Let's say it's, I don't know, 3 billion, right? So if it was, it's not, but if it was 3 billion, and we would simply reduce that fraction, do the division, and that would give me the decimal, move the decimal place twice, and that gives me the percent. The book says the answer is 56%. So I guess when we add up all those numbers, we're going to get somewhere around 2.5 billion, something like that. A little bit less than 2, or a little bit more than 2.5 billion. All right, so that was how number 6 was done. Any other questions? All right, well, obviously, I'm going to look at your homework. I'm going to warn you for today's class, you will need a compass, not literally in class, but you will need a compass to do your homework tonight, and you'll need a protractor. So
What if we don't have a compass?
you could use any circular object. You basically need to draw a circle. And it's got to be a good circle too. So a bottle cap, or not a bottle cap, a cover off of like a Pringles can would work, something like that. Anything that's nice and round to draw on your papers. You need to draw a circle. All right, the protractor is actually the more important part because we'll be measuring some angles. All right, so here's our calendar. We're going to be back in person on Monday And I know I've said this a bunch of times. We're just going to roll through the curriculum here for chapter 12. Chapter 12 is the last chapter of the book. So you can see that we're going to be finished the book in about 3 weeks, which brings us up to the second to the last week of school. We'll do a couple pre-algebra, or pre-algebra classes just to get you ready for next year. Not many of them. I think I got 3 of them. And then we'll do our semester final review and take our semester finals and go on summer vacation. All right, here's your homework for tonight. There is only 2 problems. You will be making 2 of these tonight. And as I said, you're going to need to be able to draw a circle on your page. And you're going to have to measure some angles. So you're going to need a protractor.
Is today's class easy?
Most people that can follow directions, right, find this to be a very easy class. The people that can't follow directions, can't write steps down, they will find this a troubling class because it has a lot of directions. There are many steps. The only cool thing about this is that it is being recorded. So you could play this video. I'll have it posted, I don't know, by 12. You could play this video while you're doing those 2 problems.
All right.
So page 410, 411, one of those is on 410 and the other one's on 411. We're going to be making 2 graphs today for homework, just 2 graphs. All right, the 2 graphs we'll be making today, one is called a pictograph and the other one is called a circle graph. You probably know the circle graph as a pie graph. All right, so we'll just jump right into it. I'm going to do one example of each. So 2 types of graphs today. Here's the first graph. So let's see, think about this. What would happen if instead of making a bar graph, let's see, what's this bar graph about? It says published books in the United States. All right, published books doesn't mean how many were printed. It means, you know, the number of titles. So you got a book about Thomas Jefferson, you got a book about World War II. Those would be 2 published books, even though each one might have 1 million books. So this isn't the total number of books that were printed. This is how many different titles were published. So we got the 50s, the 60s, 70s, kind of like what we did the previous time. Book titles. So let's see, it looks like way back in the 50s, there were only 10,000 titles published. But by 1980, there were 45,000 different, or a little bit more than that, 45,000 different books published. Okay, there is a different type, and you've probably seen this before. There's a different type of bar graph. Now, it is a bar graph. We give it a different name. A lot of publishing places, like when you see this in printed text, you'll see this type of bar graph used all the time because, I don't know, it kind of looks kind of neat. This is what it looks like. It's the same graph. It's the same graph, except instead of it being bars, right, or rectangles to represent the height, you see the height, except instead of there being bars to represent the height, there is literally a picture of a book, and we have multiple books stacked on top of each other. You'll have an index over here telling you what each one of these shapes of these books represents. Let's see, the big book represents 5,000 titles and the little book represents 1,000 titles. So if we look at 1950, we have 2 big books and 1 little book. Let's see, if a big book is 5,000 and there's 2 of them, 5,000 plus 5,000 is 10,000, plus another 1,000 will be 11,000. And if I go back to the previous bar graph, notice it represents exactly the same. Looks like 11,000. In the 1960s, well, there looks like there's 15,000 books published. And on our pictograph, well, if 5,000 is one book, or if one big book represents 5,000 titles, then 3 of them would be 15,000. So that is how a pictograph. Now, the obvious question is, well, how do they figure out, 1, what picture to use? And then 2, how do we figure out what numbers will each one of the pictures represent? And that is where the creativity of the person making the graph comes in. It is literally the person, the creator's choice of what picture you use and what each picture represents in terms of numbers. Now, if we go back to the bar graph, we can see that we got to go from 10,000 to 45,000. So it kind of makes sense that maybe you go by 5,000, right? The math there is a whole lot easier. But some of these bars go up a little bit past the 5,000 mark. So that's why we need to have another book that represents either 1,000 or maybe you might have it represent 2,000. It really just depends upon your data. There's a lot of creativity here. When you open up your book, you can see I left off one of the examples, but you'll see it here in a second. All right, so that is a pictograph. And yes, tonight for homework, they're going to have you make, I'm reading here real quick. Yes, that is correct. All right. So let's write this down. Pictograph. Well, it is literally still a bar graph, but it's a bar graph where the bar, instead of being a rectangle, is represented with symbols that represent the value of the bar. And yes, we choose symbols that are related to the topic at hand. We're dealing with books. Well, the symbol obviously would be a book. We were talking about, I don't know, ice cream cones, then we would probably have pictures of ice cream cones. Okay. Pictograph, and like I said, you see these are very commonly used. Bar graphs are used a lot, and pictographs are used a lot as well. All right, everybody okay with the definition?
Yep.
Okay. Here's the second one. Obviously, let's see, I'm looking at it, looks like cars. And we got a full car, we got it looks like about a half a car, we got a third of a car and a quarter of a car. So notice our index here isn't very descriptive. They only have a full car. So it's left to the reader of the graph to, I don't know, guess, surmise, figure out the percentages of the smaller parts of the car. Well, clear, if you look at 1940, at the end of 1940, that looks like half a car. If you look at the 1930s, well, that's not a half a car, it's probably a third. And then in 1920s, you can see that's about 25% of the car. Most of the time, I would say you're not doing your readers a good service here if you just have them guess at what those are equal to. So if I were making that particular graph, I would have put both the half, the third, and the quarter in there as well too. All right, so this is a horizontal bar graph or pictograph. If you can pick any one of these, for instance, we picked the 1940s. Each car is 1 million, so there's 4 full cars. That's 4 million and a half a car, so 4,500,000. 4 million. This was the same graph as we had yesterday, or the not yesterday, the day before, the last 2 classes ago, of that data of cars sold in the decades from the 20s to the 80s. All right, you can use this to answer questions, obviously, just like you can with a bar graph. So let's see, how many cars were sold in 1950? Well, let's see, I got nothing but full cars here, and each one is 1 million. So it's 1 million, 2 million, 3 million, 4 million, 5 million, 6 million, 7 million, 8 million cars. Not too challenging there. How many cars were sold from 1950 to 1960? Well, let's see, we got to consider what, 2 rows now. Well, we just did the 50s. So if we did the 60s, let's see, the 60s are right here. I got what? Well, I got the same number of cars. Look, it's exactly the same number of cars. So from the 50s to the 60s, that would be what? Double that. So that would be 16 million. Oh, that wasn't too hard. All right. Any questions on how to read a pictograph? How to read a pictograph?
Nope.
Pretty simple, right? Okay, the second graph is where we're going to spend the majority of our time, and it's where the questions tonight for homework will be on. The second graph is well, you guys know it as a pie chart or a pie graph. We will call it a circle graph, a circle graph. So a circle graph, well, it's a graph, and it shows values of categories, And how it shows those values of categories is by using little pieces of the circle. In other words, they break the circle up into parts, and each one of those parts has a representation. Notice the colors are different, the numbers are different, and the labels are different. Let's see, on this example right here, it says the titles says the world's water. World's water would include fresh and salt water. Well, we know what there's 5 oceans. I'm sorry, 4 oceans, and we have all the fresh water. And if you notice, salt water makes up most of the water on the earth. Pacific Ocean is the largest. How do I know that? Well, one, I can either look at the size of the piece of the circle in orange there. That's the largest size. Notice I also have listed the percentages there. That helps out. And then the titles there give us the indication of the separation between salt and fresh water. Although other isn't listed as fresh water. Well, if we have 4 oceans, the other water on the earth is either the water, standing water that must be in rivers and lakes, right? And that would be the fresh water. There are some saltwater lakes, a few of them. The Great Salt Lake, it's pretty close to us. That's a saltwater lake. There's a few other in the world as well. Those would be lakes that do not drain to the ocean. All right, science trivia for the day. Why are the oceans saltwater and lakes and rivers freshwater? Anybody know?
Isn't it because like all the salt is like released to like the oceans, but the lakes travel like to the oceans and they carry the salt with them.
They do. So in fact, it's kind of erroneous to say that lakes and streams are not salt water. Well, the difference is that the salt water is so small and minimal that for all intents purposes, we can't taste that salt when we drink it, which is why it doesn't taste salty. So what happens is, as you were correctly said, all that water goes to the ocean, and then through evaporation, the water leaves the oceans, right, through evaporation, but the salt stays behind. So the oceans keep getting saltier and saltier and saltier. All right, enough of that trivia. Let's go back to math. All right, notes on some circle graphs. First off, the values on the circle graph are given as percents. Or I should say they can be given as percents, right? You have the option, look, all of these numbers here, Pacific Ocean, 46.1%. So you can write those values as percents, right? Here's an example. You can also write them as numbers. Here's a different one. Class vote. Who wants to go to the beach, the zoo, or the mountain? I'm pretty sure most people would probably vote to go to the beach, and that's what this indicates as well too. But a fair number of people want to go to the zoo. Now notice these are not percentages. These are just straight up numbers. But from those numbers, you can tell which one or which piece is larger. This one's a good one because it's hard to visually see which piece is larger, the votes for the beach or the votes for the zoo. I mean, without the numbers there, you might make an argument for or against either one. But with the numbers there, it's very clear, well, the beach wins, as it probably should. So values on circle graph can be written as percent. They can be written as numbers. We go back to the maker of the graph gets to choose whether they want to use percentages or numbers. It's entirely your choice. Lastly, sometimes numbers aren't even given. Well, here's a circle graph, and let's see, composition of the school orchestra. In other words, which instrument has the most of it in this orchestra? And it's really visually easy to see that there are more violins than any other instrument in the entire orchestra. Notice drums and trombones, those pieces look to be exactly the same. I don't know. There's no numbers there. I can't tell. So when you choose to omit the numbers, well, you kind of leave it up to your reader of your graph to make some assumptions. I mean, I truly don't know if there's the same number of drums as there are flutes, but the pieces kind of look to be about the same. So just be cautious. Usually when they leave off numbers, it's because they have a very, very messy, I shouldn't say messy, a very, the circle graph has a whole lot of pieces on it. When there's a whole lot of pieces, well, there's not much room to write the numbers. So that is typically why they leave off on the numbers. If you can fit numbers in there, put numbers, either numbers or percent. But you can, no problem intended. If you want to do it tonight, that's fine as well too. You can make your circle graph without any numbers or percents. And a whole bunch of people are saying, "Ooh, I'm going to do that because that sounds like less work." Well, it turns out to make the circle graph, you got to find those numbers to begin with. So those numbers will already be calculated. So I mean, the only work you save yourself is just writing the numbers. You will have already calculated those numbers though. All right, so that's the big wind up on circle graph. Has anyone of the people that are live here, has anyone never seen a circle graph before today? Of course, you guys know them as pie charts. Okay, that's what I thought. Everyone has seen these before, but I guarantee you've probably never made one before, and that's the rest of the class. So I got 30 minutes to do a couple of these. Right, 30 minutes. So I'm going to spend the most time, and no, it's not that long of a process. It doesn't take 15 minutes to make one of these, but it certainly will take you 5 minutes to make one of these. Depends upon how fast you are. 5 to 10 minutes, I would say, would be an average of how long it would take you to make one of these. All right, so the good news is that circle graphs are very easy to read. You just read 3 of them. The bad news is that they're much more challenging to make. Right, not impossible. Right? It's not the hardest thing we've done all year, but yeah, it does require some time. So we're going to make one. All right, so there are steps to make the circle graph. This probably won't make much sense until we actually do one, but I am going to have you write down the steps. So there's just 3 steps. Step number 1 is you calculate the total. I'm going to give you some data, and the instructions will say take the data, make a circle graph. The first thing you're going to do is take all of the numbers, simply add them up. That's the total. Just like Vea's question on what was the percent, I said the first thing we do is we figure out the whole. Hey, look at that fraction right there in step 2. That's the same calculation, part over whole, except I wrote the word total. In other words, we're going to calculate the percent of each one of the pieces of the pie, so to speak. What's that 360 in step number 2? Well, remember, there's 360 degrees in a circle. So once you calculate the percent, that's the fraction part right there in step 2, you multiply it by 360, and that will tell you how many degrees that individual piece requires on the circle graph. If all of that sounded like blah, 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 that's fine. When we actually do one, it will make sense. So step number 2, and it says calculate for each pie part, right? So you're going to, I mean, if there's 10 parts to the circle graph, you're going to do step 2 10 times. All right. I don't believe tonight for homework there are 10 categories that you have to count. I'm trying to flip my book open real quick to figure this one out. I don't believe that there's 10. I gave you 2 of these to do. It's just question 1 and 2. Flipping fast. Need to flip faster. Let's see. Circle graphs. Here we go. Question number 1 has 1, 2, 3, 4, 5 parts, and question 2 also has 4 parts. So you'll only be doing it 4 times. 4 times. So that's not too bad. Not too bad. Okay. As I was rambling on, hopefully you copied down these steps. Step number 2 is the part that takes the most time. Now, the book, when you look at questions 1 and 2 tonight for homework, they put everything in a nice, friendly table for all of this stuff. The table makes sense, and you'll see why it makes sense when you do one. All right, you guys ready to watch me do one?
Yep.
Okay, here we go. So quick note before we do one, let's say that we do all those calculations and we have 3 pieces that we need to put on the graph. I'm going to choose to do this part first because once you are comfortable with this part, the first part is actually a little bit easier. So let's say that we had 3 categories, the number of people that liked the color blue, the number of people that liked the color red, the number of people that liked the color green. And so we did this calculation. That would be step 2. And we found out that red was 75 degrees, or whatever color I said. Blue was 75 degrees. Red was 110 degrees, and green was 175. How do you actually make the circle graph once you have the pieces? Well, here's how it's done. Well, the first thing you got to do is you got to draw a circle. So you grab your compass or the top of a Pringles can or a soup can or something like that, and you draw a circle. You're going to need your protractor for this, though. So there's my circle, okay? Once you draw your circle, step number 2 is you draw one radius, not a diameter, one radius. And it doesn't matter where you put your radius. I chose to put it right there. If you wanted to put yours, let me see. Let me draw another one for you. If you wanted to, pen isn't working. Come on, pen. If you wanted to draw your radius right there to start, you could. It doesn't matter where the radius goes, all right? But you have to draw one radius. All right, step number 1, draw the circle. Step number 2, draw one radius. Now we take our protractor, and remember, your protractor has a hole on it, right? The hole is right here. I can't actually physically do this right now. You're going to put that hole right here at the center of the circle, and you're going to line up. Where's the 0 on the protractor? It's right here. This is your 0 line. You're going to line that up with this part right here. So everything I just circled in blue gets lined up. The first piece of the pie that we do needs to be at 75 degrees. So we're trying to do 75 degrees. Now, 75 degrees, if I could draw this nice and, can I draw this nice and straight? Let's see if I'm able to do that. 75 degrees would be right here, right? Can you see that 75 degrees? Remember the blue line, I'll do this in red here. Remember, this is the 0 line right here. I didn't circle it. I drew a line. I meant to draw a circle. This is your 0 line right here, and we count up from 0. Let's see, there's 10, there's 20, there's 30, there's 40, so forth and so on, all the way up to 75. So remember, my protractor is actually on the circle at this point. So when I draw that, 75 degree line, it winds up being right there. Do you see that, how I did that? Like I said, it's kind of hard to do on e-learning using PowerPoint. In class, you'd have seen me put the protractor on the circle itself and draw that 75 degree angle. Hey, we just made our first piece, right? So our first piece, this area right here, right, there is my first piece of the pie. I have to do 3 of these. So I just finished the first one. Now I'm going to do the second one. Now, when I do the second one, let me just erase everything. When I do my second one, I'm not going to put the, well, I'm still going to put the hole right here, but I'm not going to line up the 0, this part right here. I'm not going to line up the 0 with this part, because that's how you draw that first piece. I'm going to line it up with this part. Everybody tracking with me? Now I have to draw not 75 degrees, I got to draw 110 degrees. So let's see, 110 degrees would be from the 0 line. Well, you go up to 110. So that would be the angle that you draw, right? Notice what I did. I went from 0, I'm counting up 10, 20, 30, 40, 50, 60, all the way up to 110 degrees. So that's what I've drawn. Now remember, my circle is actually right here. So when I draw that 110 degrees now, it winds up right there. That's kind of hard to visualize, but remember, my protractor would have been lined up. I'm going to do this in red now. Would have been lined up. The circle's lined up. Oh, come on, you. My circle would have been lined up with this, or the hole in the compass, protractor, sorry. And my 0 line is lined up with that one. Then when I trace it 110 degrees. You ready for the good news about all this? Guess how many degrees will automatically be left with the circle since I already did the first 2?
The last one?
The last one. You'll never have to draw the last one, right? Because there's only 360 degrees in a circle, and you just used 185 degrees of it. So there's only 175 degrees left. So here's if there is a silver lining in this process, is you will never have to draw the last piece. It will automatically be done for you. All right, I always do that one first, right? I want you at least be able to see that, okay, it's not too challenging of a process. Before we get into actually coming up with the 75, the 110, and the 175. It's just a bit too overwhelming if I do the whole thing from the start. So now you can see where the success will be. Now you're going to watch me actually do the calculation. So here is the calculation. You're going to have a whole bunch of words, and there's going to be some numbers. Let's see. The 7th grade voted to decide where to have the end of the year picnic. The results were the Mountain Park got 62 votes. Basically, we're going to recreate that graph that we saw at the start. Mountain Park got 62 votes. South Beach got 96 votes, and the City Zoo got 82 votes. All right, now we're going to do those 3 steps, right, that you copied down in your notes. Step number 1 is you calculate the total. In other words, we're going to take all of the numbers that we are given, and total means add, we're going to add them up. So we add them up. Let's see, 62, 96, and 82. If we add those up, let's see, if we add those up, 2 plus 6 is 8, plus 2 is 10. So 0, carry your 1. 6 plus 1 is 7, plus 9 is 16, plus 8 is 24. So we get 240. All I did was add those numbers up. Okay, so there is my, of step number 2, there is my total, 240. There is my total. Okay, so 240 is your total. Step number 2, which we need to do multiple times. How many times do we do it? Well, how many numbers did you circle? I circled 3 numbers, so I'm going to do this calculation 3 times. But here's how it's done. Start with one of the numbers, and it doesn't actually matter which one you start with. I will start with, let's see, the 62. So I'll start with the 62. 62 is your part. 240 is your total, and you simply do this calculation. Yes, you can use a calculator if you'd like. All right, so 62 is the part. 240, where did I get 240? 62 plus 96 plus 82. 62 is your part, 240 is your total, so it would be 62 times, let me catch up, 62 is part, 240 is your total, so 62 times 360 divided by 240, and you get 93, and that will be in degrees. So for my first piece, the piece for Mountain Park, the kids that want to go to the Mountain Park, that's going to be a 93-degree piece of the circle. 93 degrees. Boom, Mountain Park, 93 degrees. Now we repeat the process, but this time we're going to do it for the next number, 96. 96 is your part. 240 is your total. Do that calculation right there. Yes, you may use your calculator. Stop me if you're lost. 96 times 360 divided by 240 is 144. 96 times 360 divided by 240 is 144. I said we had to do this the number of times that we had numbers. We got 3 numbers, so we need to do it one more time. Except this time, the part is 82. The total is still 240. 82 times 360 divided by 240 ends up being 123 degrees. And by the way, if you add these up, you will get 360. Okay, that is actually the hardest part of the process, is that math right there. The circle graph, well, as long as you can, if you're handy with a protractor, it's not that bad. All right, so I got to take those numbers right there in red, and I'm going to make my circle graph. So to make my circle graph, the first thing we need is a circle. So I need to, I don't know, soup can, something. I need to make my circle. So there's my circle. Yes, I can do this nice and pretty because it's PowerPoint. All right, so there's my circle. The next thing I did, I said, I'll do this in red, is I have to make one radius. So I make one radius. Okay. I take my protractor. I put the whole of the protractor on the center. Remember, the center of the circle. the center of the circle. So I'm putting the whole of the protractor right here. I'm lining up the 0 line of the protractor right here. And I'm going to read, I shouldn't have done this in red because my numbers are in red. I'm going to read 93 degrees on my protractor and draw that line. So 93 degrees, roughly right there. Okay, 93 degrees. Is everybody okay with that? We repeat the process, except this time, well, the circle still goes on the center of the circle, but this time when I line up the 0 line, I don't line it up there. I line up the 0 line right here. You got to stop me if you're lost on this. So you're going to turn the protractor a weird angle, right? You might have to turn the piece of paper itself, right? That was what my recommendation is. You can turn your head if you wanted to. And this time I'm going to read not 93 degrees on the protractor. I'm going to read 144 degrees on the protractor. So I count up from 0. That's usually what I always do, is just count up from 0. And I go 144 degrees. And let's just say, for sake of the argument, that that's 144 degrees. Okay, 144 degrees. Cool. Why is it cool? Because as soon as you do all but one of the pieces of the pie, what's left is what's left. So there's your zoo. Now I do have to do some labeling. So let's see. The first piece was park. And there were what, 93 votes for that? The second one, I'm not 93, sorry. I just did degrees. How many? Oh, there's 62. Sorry. 62. That's better. 62 V votes. All right. Second one was the beach. The beach. It's almost beach weather. We're getting close. And that was how many votes? That was 96 votes. And the last one was mountain. Who wants to go to the mountains? There's still some snow on the mountains. You can get some skiing in. And that was 82 votes. All right. And that completes the whole thing. Now we still need to put a title. And what was this? Picnic votes or picnic choices. Something to that effect. Picnic votes. Now I will point out, and I did say it in class, it is your choice whether you put numbers or whether you put percents. We never calculated percents, we calculated degrees. So if I wanted to do percents, I would have to do this calculation again and just leave out the 360. So part divided by the total, and then move your decimal place twice to get a percent. So that's probably why most of you, myself included, would simply leave the number of votes. Okay.
I have a question.
Sure.
So you did mountain park twice.
I did. What was the last one? Zoo?
Yeah.
All right. Good catch. And I erased my circle. I didn't want to do that. I don't think I can just erase. Yeah, I'm going to leave that. Let's just, if I hit the erase thing, it erased the circle. So, zoo. Okay. There it is, sloppily done. All right. Any questions on that? So how long is this going to take you to do one?
Probably like 5 minutes.
I'd say 5 to 10 minutes easily. Yes, you can use a calculator to do that one calculation. That's fine. If you don't, I mean, someone's eventually going to ask, well, I can't find my compass, or it's in my locker at school. Well, make your best estimate of where those degrees are. Let's see, how would you do that if you didn't have a protractor? Well, let's just think about this logically. We know that 90 degrees makes a right angle, right? So there's a 90-degree angle. We know that 180 degrees is a straight line. Let's see, 270 degrees, right, would be this. In other words, from from here all the way around would be 270 degrees. And you're not going to have a 360 degree angle. So those would be my, and then anything in between would be somewhere in between. So for instance, if you were making a 150 degree angle, let's see, 150 degree angle would be more than 90, but less than 180. So let's see, 150 degrees, more than 90, but less than 180 degrees. So there is a rough guesstimate of where 150 degrees is. Do your best on this. You know, if you can find a compass, right? That's cool. All right, but I know a couple of you probably are going to say, I don't have my compass. All right, any questions on circle graphs, how to make them, how to read them?
Nope.
How many of them did I give you tonight for homework?
I think only like 2.
I only gave you 2. Now, if you have your books, open them up. I just want to point out the table that they gave you. The table that they gave you. So the table that they give you, both in question number 1 and question number 2, has 4 columns and a whole bunch of rows. Now, each row, the first row is the titles. The second through the fourth is the actual data. And then the last row is your total. So the first one are your categories, right? Cat. So for instance, you know, beach, zoo, mountain, that sort of thing. Now it's a different scenario here. Your second column is the actual data, like how many numbers, right? How many people voted? Let's see, question number 1 deals with votes or orders, sorry. Question number 1 deals with votes or orders. Question number 2 deals with pages. All right, but it's still the same thing. So your data goes in column number 2. Column number 3 is that fraction. Remember that fraction was the part over the total. Not times 360 though, just part over your total. And you can probably see why I do mine a little bit differently, because it seems ridiculous that the last column is, we'll take that and then multiply it by 360. So take column number 3 and multiply it by 360. I just combine that. I combine this step and this step all into one. Why am I saying that? Because they actually want you to fill in the table there. If you choose to do it the way the book did it, well, then you do it, you know, as you can see right here. If you choose to do it my way, well, then your table is only going to have 3 rows, right? It's going to have, well, it's still going to have the category. It's still going to have the data. But on my table, I'm just going to combine the last 2 together. So the last one will be part over total times 360. That's how I would do it. By the way, the question states, make a circle graph, right? So you're going to be making 2 circle graphs tonight for homework. And that's it. Any questions over anything I said?
Nope.
Jasmine, you still on?
Yeah, she's still on.
Let her talk. All right. She might be having an audio difficulty. She sent a whole bunch of chats. Let's see. What is the math homework? Because I was not here. So the homework is right here. What do we do with the 62? The 62 was just the total votes for that particular category. So you put it inside the actual pieces of the pie. I'm gonna come back to this, Jasmine, but I'll show you what the graph from the book looked like. Oops, went the wrong way. This was the right here. You're like, wait a minute, their circle graph doesn't look like the one that we made. Why? Because look where they drew their first radius. I always put the radius from here to here as my first one. It just makes it easier to do with the compass. Notice they didn't do it. They put their first line, they put it right here. which is why theirs goes a little bit further over. They also did beach first. We did the mountain first instead of the beach first. So it's entirely up to the user of where they put the pieces on the circle graph itself. But where does the 62 go? The 62 just goes with that one category there. So 62 was the number of votes for who wanted to go to the mountains. Okay, if you run into any problems today when you're making these, go ahead and send me a quick chat. I'll give you an answer as soon as I can. I think you guys are going to be okay, but like I said, there's 2 of them, right? Probably take you, 10 to 20 minutes to do the whole thing. And if you don't have a protractor, take your best guess, but you can find something to make a circle with. All right, any final questions? Because that's it for today.
Nope, I don't have any questions.
Okay, I believe I sent to both Jasmine and Jaden and who else wanted it? Pierce, I believe. I sent them the picture of their homework because they don't have their books.
Actually, it was me.
It was who?
Me,
Who's me?
Jameson.
Yeah, I said that. I said Jameson, Pierce, and Jaden. I'm just checking real quick to see if you guys all have your test turned in. I want to say there were 2 people left that didn't have it turned in, but everyone else, it's already turned in and graded. I'm looking at this real quick, and yes, Lily and Keegan. Macy, you still need to turn it in as well too. And Ace, you turned in page 1, but you didn't turn in page 2, 3, and 4. So Lily and Keegan, I've got nothing from you. Macy, we've been talking, chatting. You're supposed to get it done. And Ace, well, like I said, I sent you some messages yesterday. You gave me a copy of page 1, but that was the only thing on there. So make sure you get that fixed before I put zeros in for the rest of you that don't have that work turned in. Everyone else, it's already graded. We did pretty good on the test. You can check your grades. All right, I'm going to end it right there. You guys have a wonderful day, and we'll see. Oh, remember, tomorrow's Friday schedule, so different time. Let's see, Friday period 1 is what, 8:35 to 9:12, 8:35 to 9:12. Jasmine's asking one last time, what page is the homework? It's page 410 and 411. 410 and 411. Questions 1 and 2. Questions 1 and 2. Should be on the team's document. If it's not, Jasmine, I'll make sure it is at the end here. All right, I'm going to sign off. I'll see you guys tomorrow.